Welcome to the ExactCAD software basic package. ExactCAD makes add-on tools that work with Mentor Graphics Expedition ECAD software. They are intended to save time, increase efficiency, reduce errors, and produce more consistent design output from all users on your team. With ExactCAD software, you can take days out of every single PCB design project. That's a bold claim, and it's 100% true. The basic package includes 6 tools. Shapester uses existing design objects like pads, vias, traces, and planes to create other shapes. It can make plane shapes, obstructs, solder mask shapes, and much more. Netline Optimizer is like Mentor's IO Designer and IO Optimizer, but much simpler, easier to use, and more flexible. Component Groups is a placement organization tool. It helps the designer keep track of parts that belong to circuits, so they can be selected and moved as a group regardless of individual part location. Align is a simple yet powerful tool that makes placement of components and vias based on component pin spacing fast and easy. There is no interface. You run it with a hotkey. It knows what to do depending on what you have selected. It aligns parts to other parts, vias to pins, and vias to other vias. Move with BasePoint is another tool for moving components, vias, and user layer draw objects. Place Components has even more functionality for placing components. It is primarily useful when there are many similar groups of components. It puts component groups in rows or columns, then spaces them out by given values or by minimum spacing. It can also swap groups and individual components around to uncrossed netlines. The basic idea of Shapester is to create shapes based on other design objects. For example, in a power supply circuit, a group of pads from a regulator chip, some capacitors, and an inductor can be used to create a plane shape which encompasses them and joins them together. This is very useful in boards where there are many power supplies creating and delivering power to distributed devices. It also uses component pads to make plane obstructs on the same or adjacent layers, solder mask clearances for contours, text, board outline, etc. It has a copy function that lets you copy objects from one layer to other layers, eliminating the need to copy, then change the layer of copied objects manually. Here's an example of a plane shape made from a group of connected pads. If you find yourself drawing a lot of planes and obstructs manually, Shapester will save you a lot of time. Its shape customization parameters make it easy to get the shapes how you want them. Like IO Designer and IO Optimizer, Netline Optimizer uncrosses or unscrambles netlines on components where net pin swapping is permitted. The difference is that it does this with almost no setup, no special symbols, no need for making pins swappable in the part definitions, and no restriction at all on what components it works on. There are only 2 requirements to make it work. The first one, the PCB designer must know what nets and pins are swappable. Second, in the schematic, the component pins must have a named net segment attached directly to them. Netline Optimizer does not change the native symbols in any way. All it does is change the net names on the net segments attached to the pins of schematic symbols. Of course, it is best that the net segments on the schematic pins not be attached to anything but an on or an off page connector. If there are series resistors or capacitors or any other components on the nets that connect to the FPGA, their net segments should be separated from the segments that are on the FPGA pins. This way the net on the secondary device will stay put and the net will only move to another FPGA pin. The classic use case is an FPGA with hundreds of I/O pins that can be swapped around as needed to uncross netlines. The images on this page show an example of this. The interface and process are very simple. First, you select the nets you want to unscramble. You can select pins, traces, vias, or netlines, anything that causes a net object to be selected. Then you press the top button. The nets are collected and the uncrossing is calculated. The tool will ask you if you want to see a prototype of the uncrossed net lines. You can either look at them or not. Once you're satisfied that the operation will give the desired results, you proceed. The next step is to update the schematic. All you have to do is have the schematic open. The component symbols where the swaps will happen are found by the software, and the net names on them are changed according to the net pin swaps that have been calculated. Depending on the number of swaps needed, this can take anywhere from a few seconds to a few minutes. Once the schematic update is complete, the only thing left is to forward annotate the changes into the PCB. The net lines will reflect the changes and you can continue routing the board. The process can be repeated as often as needed as routing progresses. Traces can be routed from either end and on different layers. Whenever swappable nets begin to cross each other, they can be uncrossed again. This results in cleaner routing all the way to the trace destination, and many fewer vias in tight areas where you would otherwise need to change layers to jump over or under some other nets. It also results in less wrapping traces around each other near their destination pins. You will find that you are able to keep traces on the same layer much more than you would otherwise. Overall, it leads to cleaner routing and thus better signal performance. Component groups. This tool provides a simple way to keep related components together. You can make as many groups and subgroups as you want. A component can be in multiple groups. Groups can be edited as needed if the circuits change or a component moves from one group to another with a schematic update. The group information is stored in the PCB config directory, so it will be there for later use. If you forget what group a component belongs to, you can select the component and find the group it's in. The Align tool was born from the frustration of placement grids and component pin grids not matching up, and the traces going from one part to another having a lot of unwanted jogs and corners in them. Long ago, all components were made on 25, 50, or 100 mil grids, so it worked well to place all of them on a 25 mil grid and put all of the vias on a 25 mil grid as well. This made for a clean routing setup that allowed long straight traces going all the way across the board with nothing in the way. Now, most components are built on metric grids with often random pin spacing that does not match up at all with a 25 mil placement grid. Thus, if you place on almost any set grid, there will be many places where pins don't line up. If your designs are wide open with lots of space, you can probably get around this problem by allowing enough room for the traces to join up with their parts cleanly. On the other hand, if your designs are very dense and you are trying to squeeze out every last bit of space to fit all the parts in, you're going to end up with very rough routing when connecting the traces. The Align tool is built on the premise that once the board layout is complete, the board does not know or care what placement grid the PCB designer used to place parts. In practice, the placement grid is completely irrelevant to the function of the board. What is important is that the traces take the shortest, most direct path from one pin to the next, with as few corners and jogs as possible. The Align tool makes it easier to accomplish this. With the Align tool, you can align parts to other parts. They can be on either side of the board, vias to pins, vias to vias, and test points to pins. It works to align one part to another in a series connection. It works to align two parts to one part, such as with two series capacitors on a differential pair. You can also align one part to another part in a parallel connection. The pins used for alignment do not need to share common nets. The parts need not even be connected to each other. Vias can be aligned to pins or in rows, or two vias can be aligned to two pins. Move with base point. Move with base point also has no interface and works by way of a hotkey. The action is much like the move command in AutoCAD. You select some objects, start the function, select the base point with a snap marker that follows the cursor location, then select a destination point with the same snap marker. The snap marker will home in on existing objects like pin and via centers, trace segment endpoints, and the endpoints, midpoints, centers, and arc or circle quadrant points of user layer drawn objects. If the cursor is moved off of a snap object, the snap marker will follow it along any 45-degree axis. This tool is most useful for aligning a group of components to another group using connected pins as the base point and destination point. It can also be used to precisely locate components to drawn objects on user layers, such as might be included in an imported DXF file with locations for connectors and mounting holes. Place components. Place components is a collection of useful functions. Group parts by schematic sheet is used at the beginning of the layout process. On the first forward annotation, all design components are in the Component Explorer, but have not been placed on the board. When they are all selected and the distribute function is executed, the parts are all in a big pile on the right side of the board outline. The designer is then faced with the task of placing each part in the circuit it belongs to. Cross-probing the schematic can make this process easier and faster. However, there is still a lot of time and effort wasted selecting and moving parts into groups just so that they can be close enough together to start forming the circuits. This function takes a lot of the manual effort out of that process by making smaller groups of components based on the schematic sheet they are on. Depending on the number of components in the board, this could save hundreds or thousands of mouse clicks and hours of manual work. Draw through-hole wave solder clearances. This tool is for use when there are through-hole components on the board that will be soldered by a selective wave solder process. This function will ask the user for a clearance value and a user layer. It will then draw the clearance areas on the user layer and create component keepouts on the solder side of the board, which will help the designer know to not place components inside the clearance areas. The copy placement function is used to duplicate the placement of similar circuits. It is very useful when there are many of the same kind of circuit on a board. There is no reference designator mapping from the example circuit to the copy circuit required. The tool figures this out itself by using a fuzzy logic algorithm that analyzes the way the components in the circuits are connected. Align, condense, and reorder placement. These are a group of functions that help place many similar parts or many similar groups of parts. Parts or part groups can be placed in columns or rows, spaced at minimum spacing or at some other given spacing distance, and ordered by their current location or by the order of their reference designators. Parts and part groups can be reordered so that the selected netlines are uncrossed. For example, a group of pull-up or pull-down resistors might be placed near an IC. You could move them around manually so that all the netlines are uncrossed, or you could quickly place them in a row or column, then get this tool to sort them for you. If there are only a few, it's not hard to do them manually, but if there are many, it can take a lot of time and effort. This tool makes it fast and easy. You can select component groups on the fly, so placing groups of parts in ordered rows or columns is also fast and easy. Note that the component groups created with this tool are not named and have nothing in common with the groups in the Group Components tool. Both sets of groups are stored with the design, but they may be used differently so they do not share any data. For example, you might have 50 relays and resistors in a component group called Switch Matrix, but for place components, each set of a relay and a resistor would be a separate group. This concludes our overview of the basic software package. We'd like to let you know that there are many more ExactCAD software tools in development. They will be released soon. We also offer custom software design services. If you have a need for a custom solution, large or small, just for your team or group, we can help you get it done. If you'd like to test drive the software or have questions about how it works, please do not hesitate to contact ExactCAD by email or phone.